Okay, so let's do a couple examples. So evaluate the following. So number 1, let's evaluate tangent of 13 pi over 27 minus tangent of 4 pi over 27, all divided by 1 plus the product tangent of 13 pi over 27 and tangent of 4 pi over 27. Okay, before we begin, let's recall that tangent is sine over cosine, right? So I know that the SIGNs will correspond in the numerator and be different in the denominator. So I have a difference. So tangent of alpha minus beta is the quotient. Tangent alpha minus tangent beta divided by 1 plus the product tangent tangent alpha times tangent beta. Okay, so what were we given? We were given tangent of 13 pi over 27 minus tangent of 4 pi over 27, all divided by, and let me make that minus like so, all divided by 1 plus the product tangent of 13 pi over 27 and tangent of 4 pi over 27. Okay, and I know because the SIGNs correspond in the numerator that this will be tangent of the first argument, namely 13 pi over 27 minus the second argument or angle, 4 pi over 27. Okay, so that simplifies since they have a common denominator. 13 minus 4 is 9 pi over 27. 9 goes into 27 3 times, so this becomes tangent of pi over 3. Okay, tangent of pi over 3, of course, is root 3, and there we are. Okay, so let's do another one. I might need to move down. Well, maybe I can start it here. So number 2. So let's say we have tangent of pi over 6 plus tangent of pi over 12, all divided by 1 minus the product tangent of pi over 6 times tangent of pi over 12. Let me make that 6 a bit better. Okay, so recall that the SIGNs correspond in the numerator because that's sine. So let's recall that tangent of alpha plus beta has a sum in the numerator, namely tangent alpha plus tangent beta, and a difference in the denominator, 1 minus the product tangent alpha times tangent beta. Okay, so let's go back to what we were given. We were given tangent of pi over 6 plus tangent of pi over 12, all divided by 1 minus the product tangent pi over 6 times tangent pi over 12. Okay, so according to the rule, that's going to be tangent of the sum of the two arguments, namely tangent of pi over 6 plus pi over 12. Okay, so I need to get a common denominator. So I'm going to multiply pi over 6, top and bottom, by 2. So 2 pi over 12 plus 1 pi over 12 leaves me with tangent of 3 pi over 12. Three goes into 12 four times, so this tangent of pi over 4, where sine and cosine both have the same coordinate, hence tangent is 1. Okay, so now let's put everything together, all of the sum and difference formulas, and verify a few identities. So for example, let's verify the following identities. So number 1, let's say I want you to verify that sine of quantity pi over 4 plus theta is the square root of 2 divided by 2 times the quantity cosine of theta plus sine of theta. So once again, we always start with the more difficult looking side, and in this case, I'm going to start on the left. Now, why is that more difficult than the right? Well, because it's sine of a sum. So let me actually color code that second angle. We know that sine shares each term with cosine. So it's sine of the first angle times cosine of the second angle. And then the SIGN is the same. So this will be plus, what shall I do? Sine of the second angle, which I should do in purple. So sine of theta times cosine of the first, which is pi over 4. But of course, sine of pi over 4 is the same as cosine of pi over 4, which is square root of 2 over 2 once rationalized. So I can change both blue terms to root 2 over 2. And finally, I can factor out the common factor, which is root 2 over 2, times the quantity cosine of theta plus sine of theta, and parentheses. And of course, that is indeed what I wanted to show. That is finally the right-hand side of the equation. So I have established that identity. Okay, so number 2, let's show that cosine of theta plus phi plus cosine of theta minus phi is twice cosine theta times cosine phi. Okay, so I'm going to start on the left. So I'm going to write this as cosine of the quantity theta plus phi plus cosine of the quantity theta minus phi. And I'm going to set this equal to, so breaking up, actually let me write that in a different, let's do that in purple. So now I'm not going to break up each one like I have before. What I'm going to say is that cosine of a sum is cosine of the first times cosine of the second minus sine of the first times sine of the second. So that's for the blue term, to which I'm going to add the expansion of the green term. So cosine of a difference will be cosine of the first times cosine of the second, because he puts himself first, and then plus sine of the first times sine of the second. So remember, cosine puts himself first and negates the SIGN. Well, notice, what do I have here? I have a negative sine theta sine phi and a positive sine theta sine phi. So it looks like I do indeed have two cosine theta cosine phi's remaining. Check mark, that's what I wanted to show. Okay, let's do another one. So number 3. Let's show that sine of 3 theta is equivalent to minus 4 sine cubed theta plus 3 sine theta. Okay, so actually I'm going to start on the left-hand side. So I claim that sine of 3 theta can be broken down into sine of, let's do theta plus 2 theta. Because 1 plus 2, of course, is 3. So I know that it'll be sine of the first times cosine of the second plus, because the SIGN corresponds for sine, sine of the second, so that's purple, sine of the second angle, times cosine of the first. Okay. And actually I'm going to move over here. So this will be sine of the first theta. Now cosine of 2 theta, I can actually rewrite that as cosine of theta plus theta. Plus, I can rewrite sine of 2 theta as sine of theta plus theta times cosine of theta. And now I can use my sum and difference formulas. So this will be sine of theta times the quantity. Well, cosine of theta plus theta is cosine of the first times cosine of the second minus sine of the first times sine of the second. But the second and the first, of course, are the same in this case. Plus, I'm going to rewrite sine of theta plus theta as sine of the first cosine of the second plus, because it has the same sign, cosine of the first, sine of the second, all times cosine theta. Okay, so now let's distribute. So I will have sine theta times what amounts to cosine squared theta minus sine cubed theta plus distributing the final cosine to the second parenthetical. It looks like I'm going to have sine theta times cosine squared theta plus, looks like I have sine theta times cosine squared theta. Okay, so let's combine like terms. Is there anything I can do here? Well, I have a sine theta cosine squared here. I have a sine theta cosine squared here. And I have a sine theta cosine squared here. So it looks like I have 3 sine theta cosine squared theta. Let me do that in blue. Minus sine cubed of theta for this guy here. But I need everything in terms of sine up here. So what I'm going to do is I'm going to rewrite cosine cubed. So this will be 3 times sine of theta and cosine squared, I claim, is 1 minus sine squared theta. Now where am I getting that? I'm actually getting that from my main Pythagorean identity. So let me remind you guys that cosine squared theta plus sine squared theta is equal to 1. So if I subtract if I subtract sine squared theta from either side, do you agree 1 minus sine squared theta is equivalent to cosine squared theta? So distributing, what do I have? I have 3 sine theta minus 3 sine squared, sorry, sine cubed, there's 3 of them, sine cubed theta. And then finally minus, do you know what? Maybe I should have kept that blue. Sine cubed theta. Let's make that blue so that we see what I'm doing. It'll be easier to look at. And what I'll do here is I'll make the cosine yellow. Cosine squared theta, let's make that yellow. Yellow. Okay, so let's count. How many sine cubed thetas do I have? It looks like I have -4 of them, so -4. Let me underline where I'm getting these. So -4 of them. -3 minus 1 is -4. Sine cubed thetas. Sine cubed thetas. And then a +3 sine thetas. Okay, now is this what I wanted to prove? Let me go back up. Oh, thank goodness it is. Check mark. So I did. So hopefully that makes sense to you guys. I'll see you in the next section.